right, welcome back. We're going to talk about example 2, but before we do that, we have to talk about the law of detachment. So this law of detachment, this is going to be a flashcard. So please write it down, put it on a note card, study it, memorize it, all that fun stuff, okay? This is something, the two laws of the law of detachment and the law of syllogism, which is going to be the next examples. These are ones that students have had trouble with in the past. So I really need you to take the time to try to really get these, okay? Now, what I'm going to say is before this is, right, this section is about deductive reasoning. And is the process of using logic to draw conclusions from given facts, definitions, and properties. So what we're going to be doing is, this is a type of deductive reasoning, the law of detachment. Okay, and these are the properties, these are the laws, these are the rules, this is the logic we are going to follow in order to state something is true. Okay, so the law of detachment, what that states is that if P to Q is a true statement, okay, and remember that P to Q, that just means if P, then Q. So we have a conditional, all right? So if that conditional is a true statement and P is true, then Q is true. Okay? So it's going to take us just a little bit to go through a couple different examples so you can see how this is applied. I want to try to break it down for you. So when we're looking at problems, there's going to be a variety of different sentences. Okay, so this right here, P to Q, is a true statement. So the first sentence you're going to get is P to Q. It's going to be a conditional. Okay, and it has to be true. The second sentence you're going to get is going to be about the P. Okay, and that needs to be true. Then, if it follows this pattern, okay, then the conjecture, which is going to be your third sentence, that has to be Q, and we could say that Q would be true. So you're dealing with three sentences, but these first two are kind of grouped together, and then if this fits, then you can say that this Q is true. So it has to follow these rules. If it diverts any way from these rules, then you cannot say that it is valid by the law of detachment. This is the law of detachment. Okay, this is what you have to follow if they're saying prove that this is valid by the law of detachment. So if they say something like that, you should be like, oh wow, okay, it has to fit this exactly. All right. So let's go ahead and look at this first example here. It says given, okay, so this is a part of the given information. If the side lengths of a triangle are 5 centimeters, 12 centimeters, and 13 centimeters, then the area of the triangle is 30 centimeters squared. The area of the triangle PQR is 30 centimeters squared. Conjecture the side lengths of triangle PQR are 5 centimeters, 12 centimeters, and 13 centimeters. So it has to fit this pattern, right? So the first question we want to ask ourselves is the first sentence a conditional statement? If the side lengths of a triangle are 5 centimeters, 12 centimeters, and 13, then the area of the triangle is 30 centimeters squared. Yeah, it has those if and then, okay? So since it has that, what we want to do is define our terms. So we're going to write down what our P and what our Q are. If the side lengths of a triangle are 5 centimeters, 12 centimeters, and 13 centimeters, then, okay, so that lets us know that we're going to be dealing with our Q. Remember, so this is going to be our hypothesis here. So I'm going to write the side lengths. Remember, whenever you're writing your hypothesis, you never write the word if. Okay, that's just a key word to let you know that it is the hypothesis. So the side lengths of a triangle are 5 centimeters, 12 centimeters, and 13 centimeters. So if you're doing a test, if you're doing a quiz, you're gonna have to define your P and define your Q, okay? Then the area of the triangle is 30 centimeters squared. So, okay, we're not gonna use the word then, but we would say the area of the triangle is 30 centimeters squared. Okay, perfect. So, the first thing, do we have a conditional statement on the first sentence? Yes. Okay, that is true. Okay, so the first thing, yes, we have a conditional statement. The side lengths of a triangle are 5 centimeters, 12 centimeters, and 13 centimeters. The area of a triangle is 30 centimeters squared. So if we did 1/2 base times height, right? We had a triangle here, and this was 5, and this was 12. We know that the 13 has to be across from the biggest side, right? So we would go 1/2 base times height to find the area, right? Area equals 1/2 base times height. You guys all did that. Our base is 5, our height is 12, area equals 1/2, 5, oh, that's a terrible 5 times 12. 5 times 12 is 60, 1/2 of 60 is 30. Okay, so yes. Okay, so this is true. Okay, so that first thing is checked. All right, cool. So that means that the second sentence must be talking about the hypothesis, which is right here. The side lengths of a triangle are 5 centimeters, 12 centimeters, and 13 centimeters, okay? So after we get done with this conditional here, the next sentence, what is this? Is this the hypothesis or is this the conclusion? Is it the P or the Q? And this is referring to the Q. So therefore, because it does not fit this pattern, we cannot say it's valid by the law of detachment, because for us to say it's valid by the law of detachment, it has to fit this pattern perfectly, okay? So this, it says, what is it? Determine the conjecture is valid by the law of detachment. And we would write the conjecture is invalid because we have a conditional statement first, and then I'm just going to say which is followed by the Q, and it is supposed to be followed by the P, the hypothesis. So it's followed by the conclusion when it's supposed to be followed by the hypothesis. So the conjecture is invalid. I should probably say invalid by the law of detachment. Okay, so if we're talking in the realms of the law of detachment, it does not follow these steps. So it's invalid because we have a conditional, but we do not, the second sentence is not referring to the hypothesis, it's referring to the conclusion. So it's invalid by the law of detachment. All right, let's go ahead and look at the second example here. It says, given in the World Series, if a team wins 4 games, then the team wins a series. The Red Sox won 4 games in 2004 World Series. Conjecture the Red Sox won the 2004 World Series. Okay, so let's start with the law of detachment. It says it has to start with a conditional true statement. That's our first sentence. So do we have that? In the World Series, if a team wins 4 games, then the team wins a series. So yes, it looks like we have a conditional statement. If a team wins 4 games, then it wins a World Series. Okay, and that's a true conditional statement. So once we have that, we need to define our P and our Q. So if a team wins 4 games, so it's going to be not the word if, right? But a team wins 4 games, then the team wins a series. It would be a team wins the series. All right. Okay. So that's the first part. So far that looks good. Now the second sentence, that is supposed to be referred to our P, our hypothesis. Remember, our hypothesis is a team wins 4 games. So here, there's the first sentence, and then it says the Red Sox won 4 games in the 2004 World Series. So is that referring to the hypothesis? A team wins 4 games. What team? Oh, the Red Sox won 4 games in 2004 World Series. So yeah, that's talking about winning 4 games. So that is P, and that is true. Okay. So far this is fitting. Okay, we have our conditional, we have the information that fits the hypothesis, so then the conjecture must be related to the conclusion. It says the Red Sox won the 2004 World Series. A team wins the series. So yes, that is our conclusion. So our third one is Q, and that is true. So yes, this is valid by the law of detachment. Why? Well, we have to say why. Because the first statement is a true conditional, and our P, our hypothesis, is true, is equal to true. And then therefore, I'm going to use these words, not these little 3 dots, that means therefore. Therefore, that means therefore. Q is also true. Okay, so that's just how you would describe it. Well, actually all of this, you need to define your terms, because you see how I'm using P and Q and stuff, because I don't want to write out all those words. So in order to use the symbols, you have to define what the P and the Q are. So this is what you need for an answer, and this also is what you need for an answer. Okay, perfect. Let's go ahead and look at another example here. Okay. We have some given information here. Okay, we have to determine if the conjecture is valid by the law of detachment. Okay, it says, if a student passes his classes, the student is eligible to play sports. Raymond passed his classes, conjecture Raymond is eligible to play sports. Okay, so the first thing we need is we need that conditional to be true. Do we have a true conditional? If a student passes his classes, the student is eligible to play sports. So boom, that's a conditional. We have our if, and we have well, we don't have an then, but we have an if. Okay, we have a comma, and we know that that's the conclusion. So we have to define our variables here. Our P is a student passes his classes. And then the conclusion is the student is eligible to play sports. Eligible. Okay. Okay, so that's our true conditional. The second sentence, remember, by the law of detachment, we have to go by those rules. What does it refer to? The second sentence is yes, it is the hypothesis. So Raymond passed his classes. Is that referring to the hypothesis? A student passes classes? Yes, it is. Okay. So that is true. So then the conjecture, the third sentence would have to be related to the conclusion. Raymond is eligible to play sports. And that is talking about the conclusion. So yeah, that is true. So we could say that this is valid by the law of detachment, because we have a true conditional statement. I'm just going to say true P to Q because it's all listed here. And P is equal to true, therefore Q is equal to true. Now, before we move on to example 3, there's just a couple things I want to point out about all of these. We're just going to reflect on these problems. So what I want you to notice is that this first sentence, that true conditional that we keep talking about, this is almost just like a rule, right? And it's like a general rule. It's like like if you're at a school, right? It's for all the students. This is the rule for all the students. If a student passes his classes, the student is eligible to play sports. So this is a general statement. So that's a general statement, okay? And then what it does is it's almost like a rule is put in place, and then what we do is we look at specific examples, right? So for this rule to happen, is the student has to pass his classes, then the student is eligible to play sports, okay? So then this is a specific thing. So now we're looking like at an individual case. All right, and seeing if it matches this rule. So this is more of a specific case. Okay, we're not talking about all the students. Now we're talking about a specific student, Raymond. Well, Raymond passed his classes. Okay, so if we have a student and he passes his class, then the student should be eligible to play sports. And here the conjecture, this Q, is also specific. Raymond is eligible to play sports. So it's specific there too. So you know that here, this first sentence with the law of detachment, this is a general statement. And then these two sentences, they are specific. Okay, so that's just important for you to understand. Okay, this is general. And these two are kind of like specific things, specific instances over that overarching rule. Okay, so let's look at this problem before. It says, in the World Series, if a team wins 4 games, then the team wins the series. Okay, so here, this is just general again. We're not talking about specific teams. It says if a team wins 4 games, then the team wins the World Series. So this is just a general rule that was set for all of the teams. And then the next sentence, this hypothesis, this is specific. It says the Red Sox won 4 games. So this is a specific instance. And then this conjecture is also specific. Okay? So that's just something important to go when we go back to your flashcard. Okay? This first sentence is going to be a general statement. It's a general overarching rule. Okay? And these next 2 sentences, the first one has to be the hypothesis. This is going to be specific, and then the conjecture is going to be the conclusion. So we're going to have a specific hypothesis, and then followed by a specific conclusion for the conjecture. Okay, so these are both specific. Specific cases, right? So this is broad, general. These are very specific. Okay? So that is the law of detachment. Okay? When you're doing these problems, if you need to go back and watch this video again to hear me explain it, that would be wise. This is not a video that it just evaporates after you watch it one time. You can watch this video multiple times, and you're probably going to have to do that. You might have to watch it again when we get back to the end of the chapter and you have some worksheets about the law of detachment, or there's a chapter review or something, and it says the law of detachment. You might have to go back and refresh your memory. That's what you have to do to get this down. Okay, but remember, the law of detachment, it's telling whether conjectures are true, they're valid by this law of detachment, which means you have to use this reasoning. Okay, if you look at it and you read it and just out of your own mind, you're thinking about it on your own, that does not mean it's valid by the law of detachment. It's valid by the law of detachment because it follows these step-by-step rules, okay? So they're not asking you whether you think it's valid. They want to know if it's valid by the law of detachment. So you have to follow those laws and make sure that it fits for you to say, yes, therefore it is valid by the law of detachment because it fit these rules, or no, it is not valid by the law of detachment because it did not fit these rules, okay? So you got to know the rules to be able to do these problems. If you don't know the rules, you're not going to do well in the homework, the quizzes, or the test, okay? And you guys are very capable of doing well, so just make sure that you know those rules. All right, perfect. That's it. I will see you in a little bit for example 3.